Hello, ladies and gentlemen. So today's topic of discussion is going to be on scatter plots as well as lines and curves of best fit. Now, this is a topic that we have discussed in this course already, so there's going to be a little bit of review, but I want to make sure we have a solid foundation of this moving forward because we're going to be using these lines of best fit a little bit more over the next coming weeks. So let's recall, a line of best fit is a straight line that's going to best describe the relationship or the trend that we see between two variables within a scatter plot. Now, the best way to go about one of these lessons is probably just to jump right into an example. So let's do that. So in this particular example, what we have is the coach of a soccer team, and he or she has been recording data, and they want to know the relationship between the number of shots that his team takes during a game versus the number of goals that they score. So we can see the data is recorded for us at the side. Now, when we're going to create a graph here, the first thing we need to do is decide where the data is going to go. Which variable is our independent and which variable is our dependent variable. Now, in a case like this, we can just ask ourselves, okay, does the number of shots we take in a game depend on the number of goals we score? Or does it make more sense that the number of goals we score depends on how many shots we take? And saying that out loud, it's fairly obvious that option number two is the correct one, where the number of goals is going to depend on how many shots we take. So that means the number of goals is going to be the dependent variable. We often think about this as the y variable. And the number of shots we take is going to be the independent variable. We often think of that as x. So the number of shots is going to be on the horizontal axis. The number of goals is going to be on the vertical axis. So I've gone ahead and plotted that data already. Now, when we're setting this up, a couple things to keep in mind as well. We didn't say how to set the graph up. So let's look at the number of shots to begin with. For the number of shots, you can see the highest number of shots I have is 38. So that gives you a clue of how big the graph is going to be and what kind of scale you should use. Now, you always want to give yourself a little bit of extra room. So I went up to a little past almost 60. I think that's 58 on my graph. So lots of room on the right-hand side just in case I need it. I don't need to go past 0 because I can't score or I can't take negative shots. So everything to the left there is not needed. Again, I showed it just so we could see where our axes are, but there's no values that are ever going to be to the left. As far as the number of goals, similarly, we can't score negative goals, so there's nothing below. And my maximum number is 4 goals. So again, I gave myself a little bit of headroom. My graph, I would be able to graph up to 6 goals if I needed to. So once we have our axes set up, now we can go ahead and plot our points. So when you're doing a line of best fit by hand, what you're going to do is you're going to take your ruler and you're going to try to set it up so that the line that you draw goes right through the middle of your data cloud that you have. Now, what you want to do is you want to look for any weird points. So in this case, you can see I have kind of a weird point down here at the bottom. We'll address that in a minute. But for that particular weird point, I'm going to ignore that. That seems odd to me and it doesn't really fit the trend. So I'm going to draw my line and set up my ruler pretending that line doesn't exist. So in this case, as I draw my line, something like that seems pretty reasonable to me. Let me move this ruler out of the way. So we can see here that that line appears to be following the same direction, the same trend that my points are. Also note that my number of points I have above and below is about the same. In this case, you can see I have 4 points above my line, and I have 3 points, or 4 points if we want to include that weird one that we omitted, below the line. So same number of points above and below. You don't want to draw your line where every point is like this, where it's above the line or below the line. right? That doesn't make sense. You want to go through the middle. So a good indication is to count your points afterwards. You should have roughly the same number above and below, and you want to try to get them all as close to the line as possible. So I'm pretty happy with the line that we've drawn here. And now that we've drawn that line, we can go ahead and answer some follow-up questions for us. So let's take a look. Probably the best thing to do is let's bring my graph back up so we can see them both. There we go. So question number 1 is, it's referring to that odd one. So the data for 24 shots taken is odd. What might have occurred here? So we're looking at this point down here. When you have 1 or 2 points that are really kind of odd and don't fit the data, as I said, we can often ignore them when we're doing this type of analysis. And we give these points a special name. These are called outliers because they lie outside of the data that we were expecting to see. Now, in a case like this, where we have a soccer game, what's happening here? So I took 24 shots and scored 0 goals. So why might that be? What happened in this case? Well, probably what happened is we just ran up against a hot goaltender, where he or she were making some incredible saves and we just couldn't beat the goalie all game. Is that what we would expect to happen? No. I would probably expect to score a couple goals if I took 24 shots, but in this case, the goalie was just better than we were, and they shut us out. Number 2, we've already done, drawing the line of best fit. Let's look at number 3. So for number 3, they're asking us to estimate now, how many goals would I expect to score if I took 30 shots? So in this case, all I need to do is find 30 shots on my x-axis, and then let's just draw a line up here and see where is that on my line. Okay, I'm not looking for a data point because you can see there is no data point where I took 30 shots. So now let's follow this over, and it's about to here. That looks to me probably somewhere in the realm of about 2.8 or so. Can I score 2.8 goals? No, it either has to be 2 or 3. So we probably want to round in this case, and I would say it's a pretty good bet that we would score 3 goals in a case like this. Now, is this type of analysis interpolation or extrapolation? We looked at these definitions earlier. Interpolation and extrapolation are both using the data in order to estimate, in order to come up with an answer. Okay? So in this case, this would be interpolation. Why do we know that? Interpolation, I want you to think interpolation inside. So the data point that we chose is inside the data set. From 30 shots, I have games where I took less than 30 shots. I have games where I took more than 30 shots. So I'm inside my data set. So I'm choosing a point inside that cloud, inside the line, in order to make my estimation. So this is interpolation. For number 4, similar question now. However, I'm going to come at it from the other side. If I score 5 goals, how many shots do you think I took? So let's find 5 goals. So that would be about here. And I'm going to follow this line all the way over until I reach my line. This is why I always like to give myself some extra room. I made sure I had extra room both above and to the right on my graph. And I drew my line even further out. I just barely made it in this case, but my line is long enough such that I can find this, this point. Worst case scenario, I would just extend my line some more. So following this down, I'm right at 50 in this case, so 50 goals, or 50 shots rather. 50 goals would be quite a game. So if I score 50 goals, I probably had to take about 50 shots in order to make that happen. As a follow-up question, again, is this interpolation or extrapolation? In this case, this is extrapolation. Extrapolate, extra, external. I'm going outside my data set. I had to extend my line and follow the trend out in order to make this estimation. So we call that extrapolation. All right. Next question, number 5. what I want to do now is to actually create the equation of my line in this case. Okay, so how do we find the equation of a line again? We've done a number of lessons on how we can do that. An equation of the line is y equals mx plus b. So I need to figure out my m and I need to figure out my b. In this case, the line we just drew freehand. And if you're doing this along with me, your line might look slightly different than my line, and that's okay. So what I want to do is I want to pick 2 points that are really good to read. These are not the data points. The points I choose need to be on the line. So I'm going to choose, well, this point that we chose was pretty good. So this is the point 55, like that. And now let's choose another point that seems to fit our data pretty nicely. It looks like this data point right here looks pretty good. So this is 8 shots, and that's at 0.5. Now that's not a realistic number. I can't score half a goal, but that's fine. Algebraically, I can use fractions and decimals, so we're good. So the first thing I want to do with this is find the equation of my slope. So remember, slope is y2 minus y1 over x2 minus x1, delta y over delta x. So I will call this one 0.2 and this one 0.1. Again, it doesn't matter what you call 0.1 and 2, they're just labels. So we are going to do 5 minus 0.5 over 50 minus 8. So that is going to be 4.5 over 42. And that's not going to work out all that cleanly, unfortunately. So let's see if we can come up with something. No, not really. So in this case, we'll just have to round this off and bring it up here so we have a little more room. So 4.5 divided by 42 gives us about 0.1, maybe 0.11, or let's go 1.107. Try to use as many decimal points in this case as we can to try to get a nice accurate representation. So there's my slope, 0.107. So that's my m. So therefore, I know my equation is y equals 0.0107 x plus b. So now I need to go after that b value, that y-intercept. In order to do that, I can choose either of the points that I just looked at, or I could choose a third point if I really wanted, and plug it into my equation. So I'm going to go ahead and use 0.2. So my y value is 5. My x value is 50. So I have 0.0107, 0.107 times 50. So that's going to be 5.35 plus b. Then I'm going to subtract 5.35 from each side. And I get my b value as being negative 0.35. Okay, and if I look down at my equation, or my graph rather, that makes sense, right? If I were to continue this graph down, you can see I'm actually down in the negatives. So, therefore, my equation of the line in this case, y is going to be equal to 0.107. And I just realized I put an extra 0 in here. Let me fix that real quick. I didn't do it in my calculations, but when I written it down, I did. So 0.107 x minus 0.35. And there's my equation of our line. Now what we can do is, now that we have an equation, we can double check some of our previous questions. So for number 6, it's asking, okay, can we solve numbers 3 and 4 again algebraically? So for number 3, it was asking, okay, if you take 30 shots, how many goals would you expect to score? So let's plug 30 shots into our equation. So y would be 0.30 0.107 times x, which is the number of shots, so that's 30, minus 0.35. So 0.107 times 30 is 3.21 minus 0.35, and that gives me 2.86 goals. And this is essentially what I assumed would happen. If you look at our graph, you can see it was a little bit below 3. I rounded up in order for it to make sense. But this is essentially what we figured out when we were doing this. We can do the same thing here for number 4. For number 4, I had asked, okay, if we're going to score 5 goals, how many shots would we take? So let's plug that into our equation. The number of goals was 5, and that's our y value. So 5 is equal to 0.107 times x minus 0.35. Now I'm going to solve for x. So first I'll add 0.35 to both sides. So 5.35 is equal to 0.107x. And then I'm going to divide both sides by that 0.107. So 5.35 divided by 0.107 gives me exactly 50, which makes sense because I used this point in order to come up with our equation to begin with, and that was also based on our graph exactly what I saw. So I would expect 50 shots was taken in this case. Okay, so that's how we can use our line of best fit now in order to answer any number of questions. I have my equation, so now I could ask you, okay, how many goals would I score with 40 shots? How many shots would I have taken if I score 11 goals, right? Something that's way outside of my graph. I can use my equation to get a good, quick answer. And generally speaking, it's going to be fairly accurate, probably better than reading it off the graph. Anytime you read it off the graph, you're always going to build up a little bit of error that's going to be built into it. So that's how we create our line of best fit and answer any follow-up questions about it. Now, what if we have a curve of best fit? Okay, so let's look at an example like this. Oh, there we go. Now, for a curve of best fit, generally speaking, all the same rules apply that when we do a line of best fit. So if I look at this particular example, we have an environmental question where we have the amount of CO2 emissions being pumped out per year. And looking at this graph, I probably could draw a line of best fit through that, but if you look, it does seem a little bit curved. So it might make more sense in this case to do a curve of best fit. Zoom in a little bit. So here's our data. Now we can do all the same thing. When you're doing your curve of best fit, you obviously can't use a ruler. So you're going to be doing this freehand. It becomes a little bit harder. So if I'm doing this by hand, right, I'm trying to follow the data as best I can. It might look something like this. By its very nature, curves of best fit are going to be a little bit harder to get exact answers from because you're doing this estimation and you're drawing this by hand. And a curve might take any number of changes as we get further and further out, right? This line might be too far down. Maybe it actually kind of comes up more higher on my graph, or maybe it dips down lower. It's going to be harder to really decide what a good curve is going to be, and the further out we go, the harder it is to make those judgment calls. But once we've drawn a curve and we're happy with that, now we can do all the same stuff. So I could ask you a follow-up question. In this particular question, it's saying by 2020, the factory wants to emit less than 70 tons of CO2. Is this a realistic goal? So by 2020, let's take a look. 2020 is right here. And so again, following this along, it looks like this particular factory will meet their goals because we're getting just below 50 tons of CO2 in this case. So by using the curve of best fit, yes, we can still, in this case, we're extrapolating our data in order to estimate the amount of CO2 that's going to be produced. Can we come up with the equation of a curve of best fit? Well, it is certainly possible. Every function that we graph, we could come up with an equation for. However, for our purposes right now in grade 9, we are not equipped for that. We know how to do lines. We don't know how to do curves quite yet. That is something we will get into next year in grade 10 as a little bit of a sneak peek moving forward. So if we ask you to draw a curve of best fit, we're going to be answering all the follow-up questions from the graph. I'm not going to ask you to do an equation in that case. All right, so there is our review of lines and curves of best fit on a scatter plot. There's going to be a worksheet posted online shortly. I want you to answer those questions. We'll also post an answer key to go along with those. As always, if you have questions, please email, and good luck.